Okay, welcome. Today we're going to look at solving logarithmic equations. So let's go ahead and get our notes out and we'll get going. Remember, if you're falling behind in your note taking, to pause the video to get your notes caught back up. And if you didn't quite understand something the first time, make sure you stop the video, rewind it, and listen to it again. Sometimes it takes a couple times through to understand the concept. Okay, let's get ready to go. So the first thing we have to do in our solving of logarithmic equations is to review the definition of a logarithmic function. The logarithmic function is the function y is equal to log base b of x. Okay, so this is a recall. We've gone over this before. And the piece we want to look at is the domain. So when we talk about the base, well, remember the base has to be greater than 0 and not equal to 1. But our x value, our domain, are all the x's that are greater than 0. And essentially what that means in terms of solving is when we solve for x, our x has to be a positive number, and we have to look for that. Sometimes we're going to get some values that will come out negative. So again, we have to check our answers and make sure our argument is always positive. So our domain is all the x's greater than 0. All right, here's our first equation, so go ahead and write it down. We want to solve the equation log base 5 of 4x minus 7 is equal to log base 5 of x plus 5. Okay, the first thing I want to do is identify the base on the log. I notice that our logs both have the same base. They're both a base of 5. Once I identify the base, what I'm going to do next is solve by what we call exponentiating both sides. Okay, I'm going to exponentiate by 5 since our base on our logarithm was 5, and you're going to see why in just a second. So exponentiating basically means I'm creating a new base, 5, and our equation or our logarithmic expression is now an exponent. So this is 5 to the power of log base 5 of 4x minus 7. So that's what exponentiating is. What I do to one side equation to keep it balanced, I have to do the other. So again, because our base is 5 on our logarithm, when we exponentiate, it's going to be by 5. And again, this is 5 to the power of log base 5 of x plus 5. Okay, once we exponentiate by 5, we can see, because of these are inverses, because our bases match, we can say those cancel each other out. And my variable that's in the argument now comes down and he's by himself. Same thing on the right side, the argument which contains the variable, when these guys cancel out, no more logs, we have just simply x plus 5. Okay, since we exponentiated by 5, we canceled out the logs to get the arguments by themselves. And now this is simply solving for x. So I'm going to subtract x from both sides. So I'm using inverse properties of to solve my linear equation. So I get 3x on the left side. The right side, it cancels out. I'm going to bring down my equal sign. Next, I'm going to eliminate the 7 using inverse properties. They subtract 7. I'm going to add 7 to both sides. That cancels out, and 5 plus 7 is 12. So I moved all the x's to the left side, and I moved all the numbers to the right side using inverse operations. And lastly, this is a one-step equation that can be solved by dividing by 3. So our result is x is equal to 4. Okay, so to recap what we did is we identified the base first, and we did that because we wanted to know which number to exponentiate by. In this case it was a 5, so we exponentiated both sides by 5. So we could now cancel out the logarithms, leaving the argument. which was something we knew how to solve, a linear equation. And the last thing we have to do, every time we solve, we have to check our answers. So I'm going to quickly substitute it in and make sure our argument stays inside the domain. So this is log base 5, 4 times. Now substitute in the x value of 4, minus 7. Do the right side, so this is log base 5, so simple check. Substitute in the 4. We can see that our right side is going to be log base 5 of 9. 9 is positive, so we know it fits inside the domain. The left side, we have 4 times 4, which is 16. 16 minus 7 is 9, which again is a positive number. The left side also equals the right side, so these do in fact check. Okay, that's how we solve logarithms. So go ahead and jot any notes you may still have down on the side, and I can answer them in class. Thank you.